Hello, today we are going to discuss about homogeneous first order O.D.Es. Let's move to an example. The example reads, solve the differential equation, and the equation we are given is y minus x is equals to x dy all over dx. That is the question that we are being given. And the additional information is that given x is equals to 1 and y is equals to 2. Let's move to solution. So we are moving to solution. The question is y minus x is equals to x dy all over dx. So the first thing is to rearrange the variables. That is, we remain with dy all over dx on one side. So it will be dy over dx is equals to y minus x all over x. So what I've done is to divide by x on both sides. So when you divide by x here, it is x and theta x will cancel and theta x will remain. That is what I've done here. So second thing that we are going to do, it is changing variables. The next thing is changing the variables. So let y to be equal to vx. When you let that way, then dy over dx is equals to v dx all over dx plus x dv all over dx. So from here, dx and dx will cancel, will remain with only v. So the same equation, that is dy all over dx, will give us v plus x dv all over dx. So up to this point, we have dy. So dy is equals to v plus x dv dx. That is the value of dy. And we remember the main equation was this one. We had dy all over dx is equals to y minus x all over x. And we have found that dy is equals to this. Second thing, we go to so now we are moving to substitution for y is equals to dx. So the first equation was this. Dy all over dx is equals to y minus x all over x. This is the question, but now we have found dy all over dx. We have found dy all over dx, whereby dy all over dx is this, so it will be v plus x dv all over dx is equals to, whereby we have y, we said that let y be this one. So whereby we have y, we equate with the other equation is equals to all over x. So from here, x into phi minus 1 all over x. So from here, this x will cancel with the other x, will remain with phi plus x d phi all over dx is equals to phi minus 1, whereby this x will cancel with the other x. So let's take this phi to the other side. It will be this way. It will be x dv all over dx is equals to phi minus 1 minus phi. We'll move this from the other side, we take it to the other side, minus phi. So the answer will be x d phi all over dx is equals to v minus phi is 0, so we shall remain with minus 1. So up to this point, I think everybody can see. 10 let's multiply by dx. So here it is times dx times dx. So this dx will cancel with the other dx. We remain with x d phi is equals to negative dx. I think you can see what I've done from here to this point. Divide by x both sides. So all over x all over x. So this x will cancel with the other x. We cancel with the other x, we remain with this, and this cancels, remain with d phi being equal to negative dx all over x. So from there, let's integrate. We move to integrating both sides. So it will be this way. D phi is equals to minus dx all over x. This one is being integrated. When you integrate dv, it gives us v plus c1 being equal to, when we integrate this 1 over x, it is ln x plus c2. So phi is equals to ln x plus c2 minus c1. So have taken this c to the other side. It will be a negative. So you let z2 minus z1 to be equal to c. So the main answer will be v is equals to ln x plus c. But from the other side, if I can take you to the first process where we started, we said that y is equals to vx. This is what we started with on changing of variables. Y is equals to vx. So y is equals to vx. So from here, what is the value of x? The value of x is equals to, or the value of phi is equals to y all over x. This is the value of phi from this one. So where we have phi, we replace it with y all over x. And we are replacing it on this equation. So the first one we have phi. So where we have phi, we replace it with this one. That is y all over x is equals to ln x plus c. And this is the general solution. Up to this point, we are done with part 1. So part 2, it is to apply the boundaries. So it is part 2.